Okay, so problem 7.5, it says the switch in the current has been in position 1 for a long time, and at time equals 0, the switch moves instantaneously to position 2, right? Okay. Um, so for position 1, uh, we know this inductor turns into a wire. It's there's yeah, it it just here. Let me actually. I'm gonna go ahead copy two figures. This wire, this inductor has no effect anymore. It's like it doesn't exist. Boom, just a wire. Um, and off this, we can just do the circuit analysis. I'm gonna redo the figure. All right, 12, 4. Oops, that might have been too long. 4. All right. All right. So then we can just do your old universal method. V1, V2, KCL, IS, I1, I2, right? And then your EFC, IS is equal to 240 minus V1 over 12. Right? IS is also equal to V1 minus V2 over 4. I1 equals to V2 over 40. And then I2 equals to V2 over 10. Okay, and then we can plug this into Maxwell. So we can go ahead and do this. IS equals I1 plus I2. IS equals 40 minus V1 over 12. IS equals to V1 minus V2 over 4. I1 equals to V2 over 40. Equals to V2 over 10. And then our variables are IS, I1, I2, V1, V2. Cool. Copy and paste this. Right. So what we're interested is in V2 here, right? Well, it says find out V naught. Okay. So well, the current across the inductor would be I2. So where's my oh, there it is. So let me mark this here. Right. Yeah. So let's see. Yeah. I2. We're interested in the current across I2, right? And yeah, because we know that our formula for the inductor is going to be V equals L times D pi T over dt. So now this circuit looks like this. sorry. I completely ignored the left side. It looks like this, sorry. 6 ohms, 4 ohms, 40 ohms, 10, and then 72 millihenry, right? Okay, and so we can start formulating. So I'm gonna make this ground, call this V1, V2, V3. Let me write our currents. Say I1, I2, I3. Okay, you can say KCL I3 plus I2 plus I1 equals 0. In our equation for components, we know that V2, we can start with this, the inductor, V2 minus V3 equals 72 millihenry times di1 t over dt. And this di1 t over dt, I can make it equal to S in maxima, right? That you make I1 equals to V3 over 10, I2 equal to V2 over 40, I3 equal to V2 minus V3 over 4, and then I3 equal to V1 over 6. And we have 1, 2, 3, 4, 5, 6. And then our variables are going to be I3, I2, sloppy, I1, V1, V2, V3. So we have 6 variables, and we have 1, 2, 3, 4, 5, 6, 6 equations. So you go back again, maxima, put this in. So we got I1 plus I2 plus I3 equals 0. 2 minus V3 equals 2 10 to the -3 times S. I1 equals V3 over 10. I2 equals V2 over 40. I3 equals 1 over 6. I1, I2, I3, V1, V2, V3. Okay. Now we're looking at this now. These are going to be our answers. For this. Oops. Okay. So okay, so now we want to look at I1 because this is our current across the inductor, right? So let me make some more space. Just a little thicker. Let's see. So I1 equals negative 99 S, and well, we know our S is Ti1 T over T over 650. So then we have an equation that looks like this: I1 plus 9 over 6 T dt. And we want to look at our equation. I'm gonna write it right. So our equation. Oh, I don't think this. I here. Let me start by writing our equation first. So dt over dp plus yt over tau equals, okay, so 6/5 I1 plus 9 ti or plus yeah, 2 0. So 63 or okay. So am I doing something wrong? Let's see, give me 1 second. Okay, so I was looking at what I did on Maxima and I noticed an error. So I think I did it too fast. I3, so you guys can see I3 is going to be V2 minus V1. So that should give us a different result. And yeah, so I'm gonna reintroduce this because I was looking at the S and it didn't look right. So yeah, it's gonna be S. Okay, so that way we can redo all this. Okay, and so then we know that our S is going to be di1t over dt. So I1 equals negative 1 over 250 di1t over dt, and 250 I1 equal or plus di1t over dt equals 0. And so tau is going to be equal to 1 over 250. Yeah, so that's going to be our tau, 1 over 250, and use that. And then we can, so it's asking for P naught, right? So I guess we can go ahead and write the equation for I1 for t greater than 0. So I1 t is going to be greater than 0. We know our equation again looks like this. So I1t, so our current at time infinity is going to be equal 0 because the inductor is going to be drained since there is no independent source. At time equals 0, we know that it's 8. Yeah, 8. And 0, right? And then we got e to the negative t over 1 over 250. So I1t equals to 8 e to the negative 250 t, right? And now we want to calculate the voltage drop across this 40 ohm wire. So for the voltage drop across that 40 ohm wire, I'm gonna bring this down again. Oops. So we want to notice that V naught is going to be equal to where do I do it? Negative V3, right? It's going to be it's going to be yeah, it's going to be, well, it's going to be the sum of, it's going to be the sum of the voltage drop with respect to time across the inductor plus the voltage drop across this resistor. That's going to be also the function, because we know that the voltage, if we were to combine these, the voltage with respect to time would look the same as here. Right? So we can start formulating this, and we can say we know that V equals L pi t over dt. In this case, it'd be I1. So we can say 72 e to the negative 3 times derivative of this I1, which would be, I believe, 250 times 8 e to the negative 250 t. And then we would add this. We would add this, and we would say 10 times 8 e to the negative 250 t. So with this, you get 0 times 8 times 250. So you get yeah, so 144 e to the negative 250, and then negative plus minus 80 e to the negative 250 t for t greater than 0. So yeah, this would be your V naught for t greater than 0.